The last session for brine mining. So after you design all the treatment process for seawater desalination, then we have two questions for your assignment. So what's the impact of brine in the seawater you discharge, the environmental impact? And then second question is what's the brine resource recovery? So nowadays, a lot of researchers are working on the seawater brine resource recovery. So how to manage this kind of things. So that's the we have to think about then how we can make some value out of it. So what's the inside the seawater? You can guess what we can recover from seawater brine. Can you guess?
They already
seawater
from the
in the seawater there settling down or settling. So with the action, they combine the combine organic compound so when you come into waterways, they call them and like we have them sedimentation. Condition to be concentrated. Most of seawater is like that. Sodium chloride, volatile iron, and calcium iron. But then the mountain, iron, 2, iron, 4. Mercury, different come to the seawater and then behave. So mostly they are very well developed. Even they are coming to the seawater, they settle down. It's the bottom of the seawater. So every time and very difficult to behave from the seawater. So we thought out seawater. So mostly brine mining, we put say sodium chloride, sulfate, yeah, right. Was some valuable material, magnesium. Magnesium is also very valuable, and lithium. Lithium was very valuable. So calcium was valuable, and rubidium was some of the different ions can be recovered and concentrate because seawater is abundant. So you can extract even the concentration low, lithium concentration is 0.2 milligram per liter. And still, if you consider a lot of seawater, it's almost unlimited, yeah, very huge amount of seawater we have, so that we can try to recover high concentration for longer time. So brine mining is now is just becoming more important issue rather than just waste or discharge brine to the seabed. Why not we have a brine concentrate? So how we can recover from this brine resource? And that's the one of the major topics you can discuss in your assignment. So let's see. So CO2 brine. So almost 2 times higher concentration of salt. So we have sodium, potassium. Potassium is also fertilizer, and chloride, magnesium, calcium, sulfate, strontium, rubidium, lithium, and then vanadium, boron, gallium, molybdenum. So there are many different materials can be recovered. So multivalent ions and monovalent ions we can separate first, like a selective calcium precipitate, sodium carbonate, and then we can produce a calcium carbonate. So calcium carbonate, well, we can use calcium carbonate. So calcium carbonate is behind this. So where is it from? There's all calcium. Calcium concentration. So we also see carbonate. Calcium carbonate is precipitate. Normally, you have a calcium carbonate binding, it doesn't get the whole calcium carbonate dry, very acidic. This is the calcium carbonate. This is ionized form, similar to the lithium, and extract which CO2 calcium carbonate precipitate and the white alcohol. Yeah. So that's the one of the way we can create the construction calcium carbonate, and we have also monovalent ions. It's a little bit more difficult to separate compared to the cationic and then magnesium divalent ion. So advanced nanofiltration can separate monovalent ion and then divalent ion. So you can have a different crystallization method. So increase the pH. So magnesium can precipitate magnesium hydroxide. So increase the pH, then magnesium hydroxide can precipitate at the bottom. So magnesium is very important. Our mineral also, magnesium metals is very useful. It's very expensive. So we can also recover magnesium, and we have also some of the water evaporation and water, the concentrate for the monovalent after nanofiltration permeate. And this divalent, like scandium, indium, vanadium, molybdenum, gallium, and then this is monovalent, so rubidium, and then boron, lithium, and byproduct of sodium hydroxide. So sodium chloride, there are many concentrations of sodium. So sodium chloride is less than the table salt, like you salt. The table salt, we produce a lot of sodium chloride, but then sodium chloride, okay, sodium hydroxide, if you can produce sodium hydroxide or HCl. I prefer this is more high than sodium chloride salt. So people can make it sodium chloride, then sodium is possible, but the value of is not really less than sodium hydroxide. People try to make the more sodium hydroxide. What's the table salt? In fact, table salt is from seawater. So they collect seawater and solar evaporation, continuously, yeah. They evaporate water from seawater and they harvest them. Seawater salt, because you find seawater salt in the market, right? So that's the way of the natural harvesting method for the colony. So that's the way we can recover resource and then produce the good quality of. So let's see the value. So this is the concentration of the water and price. This is water. So you can see the gold concentration is gold is there. Concentration is here. But if you see the sodium chloride, concentration is very high, 50,000 milligram per liter. 35%. But this one is the price. US dollar for 1 kilo. So when you harvest 1 kilogram of this salt, so how much is money? $1, $0.1, $10. Some of them are $10,000. Like gold, white gold, they are, yeah, and what is that? 1 kilogram. So you see what they have, but the concentration is very, very low. So you can see the lot of different animals, you see what. So which one is the most suitable? Economically bio recovery process would be moving. You can see that rubidium chloride, lithium carbonate, bromine, magnesium. So that's the price value. So bromine, magnesium, and lithium, 1 kilogram is $10. Rubidium, 10,000 1 kilogram. Rest of the sodium chloride, $0.2 1 kilogram. Sodium hydroxide, $0.8 kilogram. So based on this one, we can decide which one we first target, then we can target to harvest this resource from seawater Brine. And then you can sell it. So that's how we can create the value of the resource recovery process. So let's see what's happening in the different country. So this is the example of Saudi Arabia. So there are many desalination plants. Then they have a desalination plant like this way. Dual media filter, cartridge filter, nanofiltration, separate the monovalent, divalent, and seawater RO, BWRO, post-treatment, and drinking water. So they utilize nanofiltration to separate monovalent, divalent, and sending to this brine concentrator. So brine concentrator will be utilized for crystal. So they crystallize and then produce the 25% of the sodium chloride and then produce the sodium chloride salt and bromine. Can be utilized some of the pharmaceutical chemical materials, and then they can utilize the bromine. So that's how they like to recover the value. So look at what could be the best compound we can extract from the seawater, relatively large volume, relatively higher price. So you can see sodium hydroxide. So when you treat the 1,000 cubic meter of seawater brine, so US dollar is almost 12,000 sodium chloride. So you have this much of your brine, and you can produce the huge amount of sodium hydroxide, which can give a lot of value. Second one is magnesium metal. Magnesium metal can be a good value of $8,000 for 1,000 cubic meter of seawater brine, followed by HCl and hypochlorite, and then sodium chloride, rubidium chloride, potassium sulfate, calcium chloride, bromine, calcium carbonate, and followed by lithium and cesium and iode. So most of resource up to here, bromine, they have the top three is sodium hydroxide, magnesium, and HCl. For the pharmaceutical purpose or industrial application, you can utilize. So that's how you have a value out of it. And then sodium chloride, as you mentioned, table salt. In fact, table salt is cheaper. So NaOH, HCl, convert. We have a bipolar membrane technology to create this kind of material, and then you can have a higher value than the sodium chloride. Of course, we produce a lot of sodium chloride, so you can sell as a sodium chloride table salt. It's also possible. Rubidium, potassium, calcium, bromine. And then this is the potential revenue also, magnesium sulfate. And then sodium chloride, magnesium chloride, rubidium chloride, bromine. So these are the also more potential value we can target, because magnesium itself, it can be metal, magnesium metal, magnesium sulfate, magnesium hydroxide, magnesium carbonate. So they have a different kind of chemical. So every chemical has different parts, depending on the purity. So how you pure, yeah, you will have a better part. So that's the reason why some of technology is to incorporate and then it goes to language metal, some of technology, language sulfate, and it is the way to produce. Depending on what material, what molecule you need, you can design and then produce from the seawater brine, and we can have a value out of it. Also, this is the mineral recovery. So you can see the magnesium 40% from ocean. So in fact, magnesium is produced from seawater. Yeah? Why not from brine? Yeah? So we can also combine our magnesium recovery with the seawater desalination brine. Also, 1/3 of the water supply of salt come from sea, and cooking salt, potassium, like a fertilizer, agriculture fertilizer, potassium, you can produce you have
fertilizer compound from seawater, also bromine, iodine. Yep. So this is the concentrate precipitate. So when you have a higher concentration for your brine, higher and evaporation, membrane crystallizer, you can precipitate calcium carbonate, calcium sulfate, depending on your concentration, and sodium chloride, magnesium sulfate, potassium chloride, magnesium chloride, and depending on their concentration, they can precipitate. So you can have a different concentrate, and then you can have a precipitation, different material, calcium carbonate, sulfate, sodium chloride. So you can series precipitation of the crystal harvesting can be achieved from the concentration. So this is the sequence. So initially, calcium carbonate is easy to. So calcium carbonate is, as you mentioned, cement. Yeah. So construction material easily recovered. And then calcium sulfate, the next. And sodium chloride, magnesium sulfate, magnesium potassium chloride, magnesium chloride, and then magnesium metals. You can try to recover. So that's how we can achieve. So there are many technology. Yeah, you have BWR, SWR, ultra high pressure RO, and you have a distillated membrane multi-effect evaporator, also crystallizer, so how you can make more evaporation and crystallize your salt. So that's the energy you need more consumption. However, you can also produce the different quality of your mineral. I just skip this one. Also, this is an example of some of the specific ultrafiltration, nanofiltration. They precipitate calcium carbonate. At the same time, magnesium hydroxide, and then this can be produced magnesium metal with the electrochemical process. And then you have a lot of different magnesium sulfate, chloride, magnesium oxide, calcium sulfate, calcium carbonate, sodium sulfate was produced from this section. At the end, also you have some of the potassium fertilizer, potassium chloride production, then further concentrate, sodium chloride, and medium extraction, medium extraction. So you can have a different technology step by step, and you can have a different ion production line. So this is the example, like magnesium. So magnesium, seawater, sunlight, and then they have a magnesium hydroxide precipitation. And then from magnesium chloride, you have this ionic conversion to Mg2 plus to Cl minus. Then put the electron. The electron to Cl creates the chlorine gas. And cathode, you have two electrons combined with in the cathode and produce the magnesium metal. So you can create the more magnesium metal from your magnesium chloride compound. Also bromine. So bromine concentration is 50 milligram per liter. So when you put the chlorine. So they create the bromide ion to oxidation bromine, Br2. So this is gas. So this gas can be also utilized with the sulfuric oxide. So seawater goes there. The bromide concentration, they chlorinate, then bromide oxide, produced bromine gas. The bromine gas with mixture with sulfur oxide, and then they are coming to this bromine high concentration. So they can also utilize the bromide ion in seawater as a bromine gas. So bromine is very much important. So finally, they have a liquid bromine concentration in this condensated bromine from seawater brine. Also rubidium. Rubidium is $10,000 per kilogram. So concentration is 0.2 milligram per liter. It can be used high precision laser, medical application, also rubidium quantum navigator. And then this can be used for the GPS as well. So now you can see a lot of data center, a lot of satellite, of Starlink, that are, yeah, I perceive that water of force and improvement demanding ability. So we do no bigger, not like a land mining operation. It has to be little bit from here, little bit from here, combined with a different mineral. So there is no such rubidium mining site. So seawater would be a good opportunity. We can try to recover seawater rubidium concentration because land or rock mining is not available. So we can utilize the potassium, cobalt hexacyanoparate as a ion change nanomaterial and produce this rubidium replaced with this nanomaterial. So potassium replaced with the ion change with the rubidium and then produce the good quality of your rubidium recovery. So this is the also lithium. So lithium is I don't have to mention how lithium is. Yeah, rely on the lithium mining blocks. Australia is one of the largest produced lithium compound in the world. Even seawater, we have a lithium concentration 230 billion tons. So if we can recover lithium from seawater, so this is the huge impact for our lithium for battery. Yeah. So there is the several method, absorbent or ion exchange and electrochemical process. So you can utilize the several ion selective process and can recover high purity of the lithium concentration. So this is the one of the example. So this is commercially available for your absorbent. So this is aluminum hydroxide ion, lithium manganese oxide, lithium titanium oxide, manganese and titanium oxide. So you have a lithium. And then what happens is the hydrogen is here. And this is one of the process for the aluminum or manganese. So in the lattice of the molecule, so they replace with the lithium with hydrogen. The lithium hydrogen replacement can collect more lithium in this nanomaterial as an absorbent, and there you can make a high purity of metal oxide absorbent. And this is what's the comparison of aluminum, manganese, titanium comparison. And this is the also electrochemical lithium capturing system, utilizing the electrochemical process. You can selectively capture your lithium concentration and produce the better way of the purity of the lithium. So, what do you think about your brine mining in the future from silver?
Now maybe I think that impact really the marine ecosystem change. You know, people concentration of concentration. And then, you know,
I see there are lots of water. You take this carbon. It's really not.
that's why we have a design data. Impact not that if you compare to our visual. That's why we do. It's not obvious to impact, but you learn to mention. And of course, you get produce water, or shake and produce water, even coal mining. There are a lot of impact now. Bring the, land and collect, coal or gas or oil, then contaminate them. Emulate that was stated that land with very some of the other impacts that are. But compared to this map, always impact environment. Like the silver, that is education, quickly value in the silver and they are continuously growing. Like Carl, people like holiday visual, the big side and big one, right side, there is never big switch the other way. Current will continuously go this way.
And after using the brine one, then we have to exactly we don't put that as water. We already take it here, we already take. I think we can be telling that. So then normally the water without the minerals. So we water.
I could say lithium could be there.
We already take it from the mining.
No, just mining, yeah. Today it's a take of prime time. That's the discharge to the ocean. Then lithium is a very strong thing. They made after the argument, like the same, so you chloride in parties. I think in the drinking water, you're drinking, that your consumption medium from the even though but there is very, very small from the function of water.
We are learning how to display. Separate the lithium. Separate the from the lithium. If you already use by brand mining. But it's not real, it's like on the future prospect, like was scan, you think over, we have it from that.
That's it.
Okay.
How they are trying to
Okay.
they are not trying to be further.
So what she's asking is after, if we successfully do the brine mining, the better the fresh water, that's the remaining discharge water, we are like discharging into the ocean here. Yeah, same thing.
And the remaining and when you do find what can be your fine? It doesn't need to goes to your drinking water. When no water, you
All water would be
evaporate and then goes to the this is like
the
distillation.
releases.
Yeah.
Release process.
You produce more water, you cover it, right?
It's
Not because we need a salt.
Yeah.
To recover salt, even sodium chloride. That's the, we produce more water combined with our atomic, then dry this to the water and produce more water, and then they can produce drinking water. And salted rather than discharge and continuously harvest and separate and recycle and that's the item, but currently their own fish back to the person. So that's how we like to do in the future of the perspective. So we have our design tomorrow. So you can come 9 a.m. and come through. Thank you. Then can continue tomorrow for raising our design by manual activation. Do you have any question for today, please? Okay. So we will continue to utilize the computer design, which is what we can try slowly tomorrow. After this class tomorrow, you will have a more confident to design seawater desalination plant. So if you don't have any more question, yes, we can finish our class today, and then tomorrow. Also, you can install your software in your computer. Yeah, Wave software. Have you looked at the Wave software? You did, right? So it works well? You don't know how to use it. Okay, so that's exactly tomorrow, our overall